Hello. Okay, be sure you sign in. Okay. Oh, all right. Please continue signing in as you show up. What I'm sharing is my home screen in Canvas for this class. And if you notice down here, I have it in student view. You click on files. And you click on exams and reviews, and you'll notice that there's one there for exam 2, which is going to happen next week, which is what is that? 7 days from today, the 27th. That means Monday's a review. Okay, and there are 3 files in here so far. There's going to be another file put in there because there's not enough. Haven't tortured you enough. Okay, no. And what's going to go in here, what is in here, is this is the worksheet that has all the steps you're required to do when you're graphing a polynomial function. And here are 10 problems, and we've done some of those. Okay, thank you for letting me know. Okay. And let me drop out of that. And this is exam 2 review. And I'm going to put more problems in, but they're going to follow this format. I mean, this is the format of the exam. Everything we've done since the last exam, except for the matrix stuff. So that reminds me, I probably did a matrix. We'll follow this format. And you can't see me. Oh, yes, you can. So this is what the exam will look like. And there might be an additional question or two, but you basically have 3 problems. You will have 2 rational functions, and you will have 1 polynomial function that you're going to be asked to find all this information about. All right. There's 8 things you're asked to find or do. Okay. The finding is finding the asymptotes, the intercepts, and other points. The doing is the graphing, and so you're graphing you're graphing asymptotes, you're graphing points, and you're sketching the graph. So you have 8 things to do for number 1 and number 2. Number 3, you have these 11 things you're supposed to do. Some of them deal directly with the graphing, like J and K. And everything else is you're finding things or you're stating properties. So like describing the end behavior. I tell you, you need to show me all your work. When describing the end behaviors, you don't need to show me work, because describing the end behaviors is telling me the work. Okay. List all the paths. So there's work involved in finding the possible rational zeros. Using Descartes' rule of signs, there's a little bit of work involved with that as well. Checking for 1 and -1 is 0. There's some work involved with that. Show me all that work that you do. If you're punching things into the calculator, you put down what you're punching into the calculator. If you're putting a number into f of x, then show me how you're putting that number in for x. So if you put 2 in for x, you need to write down 2 cubed plus 3x squared minus 3 times 2 squared, and then minus 13 times 2, and then minus 15. And you graph appropriately. So I noticed here, this goes 1, 2, 6. Oh dear. Oh dear. With the y-intercept being -15, that's going to be right there. So you might want to change the scale to fit the points. So instead of going by 1 each time, maybe going by 3 each time. So that'd be 3, 6, 9, 12, 15. So -15 would be here instead of down here. So -15 would be here. So it would squunch the scale towards the y-axis. So all the points would be in there. Okay. So you want everything between the two outside zeros, everything between the two outside zeros to show up on the graph. It doesn't matter if or just the next number after the right hand side goes off the graph. Just list that point anyway. Okay, just show that it goes off the graph before it gets to that X value. Okay. That's all. All right. So there is work involved. Write down the work. You have to show all the work. Does it say up here? Show all work. Work the exam. This is an exam review, but it was one of the exams I used. Okay. So work the exam on notebook paper. State the reasons of properties rules for each step. State why each way an equation or formula is used, and state what variables is used. What variables used represent. Okay. And then give as much detail as possible. What's important here is giving as much detail as possible. The formulas and the variables used is not so much important. But sometimes stating a reason or a property for doing a certain thing can help me understand why you did a certain thing that I don't understand why you did it. So if you tell me why, then that'll explain some things. Okay. And that give as much detail as possible should be stated here as well. Probably, well, this is for all the problems. Show all the work is for all the problems. So I'm gonna close that down. And this is a worksheet we've been working off of. As a matter of fact, this is the worksheet that, yeah, these problems here are the problems we've done in class, or that we've done in class came from. And I'm going to stop sharing now because you have that to download. And you may use those. So today I'm going to continue doing the reviewing of graphing polynomial functions. And so Monday I will focus on answering questions from the review. So I'm going to give you more problems than we can go over on. So I want you to work as many of those as you can. And if you have questions about how you're doing it, please, you don't even have to wait till Monday to ask me about them. If you're having issues with, well, I'm not exactly sure how you find this, that's the time to send me an email or request a Zoom meeting. And we'll do a Zoom meeting so I can help you understand. Because I don't want you to come into an exam confused or lacking information that you have. So don't hesitate to ask. And that's why I like to have my review days, being you asking me questions about the review. And, well, what if I got this, what, how did it, how come I got it wrong? How come it's this and not this? And that? How do you do this part? You know, that sort of stuff. So I like to focus on how you're doing with the mechanics of solving the problems or doing or graphing the functions, and not so much me doing the work. I like to explain things more than I like to just do them without explanation. So what I'm going to do now is I'm going to do one of the things from the list of polynomials that was given to you. If you look at number 10, I'll do that one first, because there is a potential for me putting x to the 4th power on the test. Right. So there is potential for x to the 4th power showing up on the test. So that's going to be x squared minus 9x. Minus 9x to the 3rd power plus 27x plus 27x to the 2nd power minus 25x plus 10. 25x there was kind of slow. Okay, so this is my f of x. And I usually do this right away. I usually write down what f of negative x is, because I'm going to have to use that. I'm going to have to use that on letter C. So I like to set that up to begin with. If it's an even degree, x to that power, negative x to that power, so negative x to the 4th power is just x to the 4th power. So we get x to the 4th power. Negative x to the 3rd power is a negative x to the 3rd. Right? So if I do negative x to the 3rd power, it's going to be the negative of x to the 3rd power. So I'm going to end up getting a negative here times a negative, which makes it plus. So if it's an odd degree term, I will change its sign. Right? Negative x being squared is x squared, and so I'm just not changing the sign on the 27, so it stays plus 27x squared. Negative 25 times negative x is a positive or plus 25x, and the constant is constant, meaning it doesn't change.
Sir, on the files on the worksheet, the 27x and the 25 are switched. It's supposed to be 25x squared and then plus 27x.
Thank you. That would have frustrated the hell out of me as I was doing the rest of this. This is 25 here, right?
Yes.
And this is 27. Thank you.
You're welcome.
Boy, that really changes things. Okay. So now I start, now all I have to do is, I don't have to worry about what f negative x is. So now we're going to describe the behavior. So the degree, what's the degree of this polynomial?
4.
4. Is that even or odd?
Even.
Even. An even degree polynomial function. Are the end behaviors going in the same direction or opposite direction?
Same.
Same direction. So they're both going up or they're both going down. What are they doing here? Are they both going up or both going down?
Up.
Up. So based on y equals x to the fourth, both go up, or both ends. I should say that. I should say both ends go up. Or you could say as the absolute value of x goes to infinity, which is saying as x goes to positive infinity and as x goes to negative infinity, f of x goes to positive infinity. So it doesn't matter whether I'm going to negative infinity or positive infinity. Both directions are going to positive. So they're going that. And they, or you could do the arrows, which is like this, or you could write a parabola like that. Or, you know, saying both ends go up. Whatever we can use. Now, when listing the rational zeros, we need to look at certain numbers to determine what the rational zeros are going to be. With the possible rationals. So, by the way, how many zeros? What's the most number of zeros this polynomial could have? Are real numbers?
4.
4. The degree of the polynomial tells you how many zeros it could have. We have up to 4 real zeros. It does have 4 zeros. It's just that they're not all real zeros, then the rest of them are going to be complex numbers. And that's what we're going to get into after the test. But this test is the last you'll see of major bracket like this. Okay, so what do we use to find the possible rational zeros?
P and Q.
P and Q. So we want to find our P values and our Q values, because what are we going to do with those two values?
Divide them.
Divide them. P over Q or Q over P?
P over Q.
Which is why I wrote it that way. PQ. So the numbers for P, where do I get those from?
Constant.
The constant. My phone is buzzing over there and it's making my watch vibrate. My daughter had an interview today. She's texting her mother and me about how it went. I don't know how. Anyway, I don't have time to. So the constant, what's the constant?
10.
And what are the factors of 10?
1, 2, 5, and 10, plus or negative.
Plus or, thank you for adding that. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. We have a total of 8 factors for 10. What are my Q values based on? Where do I get my Q values from?
The leading coefficient,
The leading coefficient. And the leading coefficient is?
1.
So what are the factors of 1? That's the
1.
easiest.
Plus or minus 1.
Plus or minus 1. Thank you. So P over Q implies I'm dividing each of these numbers by each of these numbers. So that's going to be 1 divided by 1, which is plus or minus 1. And then we get plus or minus 2, plus or minus 5, and plus or minus 10. So our potential rational zeros are the factors of 10. So that was A, this is B. Letter C, we're going to use f of x and f of negative x to help us determine the positive and negative zeros by using Descartes' rule of signs. Descartes' rule of signs state that the number of sign variations is the maximum number of zeros that are positive or negative, depending upon which of these two functions you're looking at. So for the number of positive, we look at f of x. For the number of negative, we look at f of negative x. And so we count the sign changes in f of x to determine the number of positive. So we have a positive to negative, so that's 1. Negative to positive, so that's 2. Positive to negative, that's 3. And negative to positive, that's 4. Guess what? I used up all the potential zeros, which is 4, with the number of positives. Because if I look at f of negative x, they're all positive. There's no sign change. So the number of zeros I can have, so I can have 4, 2, or 0 positive real zeros. Right? Because it's either the number of sign changes or less an even integer. So 4 minus 2 is 2, 2 minus 2 is 0. So this is the list of possible reals, the numbers of possible real zeros. If I have a positive 1, then I will have at least 2 and possibly 4. Counting my sign changes here where there's no sign changes, so that means there's no negative real zeros.
In a situation like this where you would have no negative zeros, should you still use like synthetic division to find the negative? I mean, look for negative zeros, or will you just use that to find negative points for the graph?
Yeah, for negative points. Right now, we just cut this number in half. So the potential rational zeros are just 1, 2, 5, and 10. No negative. So yeah, when you're looking for the zeros, you're just going to be doing 1, 2, 5, and 10. Because there's no negative real zeros here, you know right away negative 1 is not a 0. Now I can see what negative 1 will give me because that goes here for appropriate points. Does that make sense? I think that's what you were asking. The only reason to put a negative number in there is to find an appropriate point.
Yeah.
And negative 1 is to the left of the smallest real zero because the real zero is going to be positive. And so -1 takes us on the other side of the y-intercept. So it's a good idea to see how fast it's growing on that end, because it's going to be growing at that end. And so to find out what f of -1 is, I just add my coefficients here. 1 plus 9 plus 25 plus 70 plus 27 plus 10. I just happen to know what that is. F of -1. F of -1 equals 72. Because I worked this problem last class. So I have -1, 72. Now, to find out if 1 is a 0, I look at f of x and I add those coefficients. So f of 1 is going to be 1 minus 9 plus 20, was it plus 25 minus 27 plus 10. If I put 1 in for x, all I'll get is the coefficients. Because x to the 4th is 1 and 1 times 1. X to the 3rd is 1, -9 times 1 is -9. On down the line. So I don't even need to worry about what it is. I know what it is. Boy, this is a 10. All right. So if I combine my negatives, I get a -36, -9 and -27 make for -36. And 1 and 25 and 10 make for a +36. So that is 0. So f of 1 is 0. So 1 is a 0. Yeah, and this is how come I knew that f of -1 is a positive 72, because this -36 would have been a positive 36. And 36 and 36 is 72. Cheated. Okay. Not really. Now, what am I doing now? Oh, now we're listing all the zeros. I know 1 is a 0. So I'm going to start right away by doing synthetic division using 1. So I can take out, so I know that 1 is a 0. And that tells me that x minus 1 is a factor. And that tells me that the point 1, 0 is an x-intercept. So finding that 1 was a 0 also answered part of E, F, and Q. Nice, huh? So now we do synthetic division with 1, and my coefficients are 1, -9, 25, -27, and 10. And I know my remainder down here damn well better be a 0. The remainder theorem tells us that. And so we bring down this 1, multiply by 1 gives us 1. That gives us a -8. And when I multiply by 1, it stays -8. And 25 minus 8 is 17. 1 times 17 is still 17. And 17 minus 27, or a -27 plus 17, is a -10. 1 times -10 stays -10, and 10 and -10 make 0, because they're opposites. When you combine opposites, you get 0. Okay, so now we have that done. Sometimes, just on a lark, I'm gonna see if 1 is a double root. That might simplify things. Well, I could move on to 2 and then 5 and possibly 10, but I'm gonna check 1 again, just because I can. And if I get a remainder of 0 over here, I will be overdoing. Just by checking. Okay, so 1 times 1 is 1. And -8 plus a positive 1 is a -7. 1 times -7 is -7. 17 minus 7 is 10. 1 times 10 is 10. And here I have opposites again, so that does give me 0. So 1 is a double root. So I state its multiplicity. Whoops. Forget a very important part of the word. Multiplicity, eyes in multiplicity of 2. Which means I'm multiplying 2 of these factors together. X minus 1 squared. And that means this is a double root. That means it's going to touch, it's going to come down and touch it, or it's going to come up and touch it. So at 1, 0, it's either going to bounce off, it's going to come down and bounce back up again, or it's going to come up and bounce down again. So that's what that multiplicity is telling me. So now what I have is this. So what I've done so far is factored this f of x to x minus 1 being squared times x minus 7, x squared minus 7x plus 10. This was the first depressed equation. This is the second depressed equation. And I set this part equal to 0 so I can find the more factors here. And this factors quite nicely. Leading coefficient is 1, so it's going to be an x and an x. The constant is 10, so the factors of 10 that add to 7. Well, that's 2 and 5. But to get a -7, they both need to be negative. And so there I factored it. X minus 2, x minus 5. And now I set this portion equal to 0, so I need to set each factor equal to 0. X minus 2 equals 0. X minus 5 equals 0. Adding 2 in the first case, we get x equals 0. X equals positive 2. And adding 5 in the second case, we get x equals positive 5. So 2 and 5 are zeros. Well, we knew that from here. If x minus r is a 0, then, is a factor, then r is a 0. And r is an x-intercept, 2, 0. And 5, 0. Now, you look at the list of zeros and you say, but there's only 3 of them listed. Yeah, but one of them is a double, and so we count that one twice. So we do, in fact, have 4 zeros with 3 numbers because one of them repeats. If I factored that out, it would be x minus 1 times x minus 1 times x minus 2 times x minus 5. And so 1 shows up twice, giving me a 0 2 times. Gives me a 0 here and here. So yeah, we do have 4 zeros, even though one of them repeats.
So how would that show up on the graph?
What?
How would that show up on the graph? Would there be like 2 ways in which it connects at that point, or?
No. What happens when it has a multiplicity of 2? The graph, what happens? It just bounces off there, right? It doesn't pass through, it bounces off.
That's okay.
So when sketching the graph, you understand that it's just bouncing off of that. So that's how it shows up in the graph. When you have an even multiplicity, it's just going to bounce off the graph, off of the
Gotcha.
So bouncing off the floor, or bouncing off the ceiling, that's what happens there. But at these other 2 points, and since their multiplicity is 1, it just passes through. Now, the easiest question on this test is letter H. What's the y-intercept?
10.
10. I almost always list it as a point. But if you just wrote down 10 as the y-intercept, that is acceptable. Because I separated out the x-intercepts and the y-intercepts. So I'm going to erase all this stuff over here because I need that to graph. So at -1, it goes all the way up to 72 up here, somewhere, wherever 72 is going to wind up. And it probably won't be on my graph. And at -1 is a 0. I mean, positive. Trying to keep my scale the same. +1, and then +2, we have zeros. And then 3, 4, and 5, we have zeros. I know at 1, it's going to go up because of the end behaviors. At 1 and 5 on the outside, it's going up. And 1 has a multiplicity of 2. So that means it's going to come down, touch here, and bounce back up again. And at 2, the multiplicity is 1, so it's just going to pass through. And so it's going to come up here somewhere and come back down again. And so I'm not going to actually draw that in yet. And then at 3 and 4, it's going to be down here because that's what's going to happen here. It passes through at these 2. And then at 6, it's somewhere up there. So I only need to find 3 more points. I'm finding 6 to see how fast it's growing. Chances are it won't even be on my graph. But 3 and 4 tells me how far down this way it goes, and approximately where the that relative minimum. And for x to the 4th, it will be an absolute. If you have an even degree polynomial function, you will have either an absolute minimum or an absolute maximum. You will have one with an even degree, like x squared. So now we start by finding out what happens at 3, 4, and 6. I can do that by doing synthetic division, or putting them into the factored form, which is the method I prefer to use, which is what I'm going to do. Much to people's chagrin. Okay, so f of 3, I'm going to get 3 numbers. I'm going to do 3 minus 1, which is 2, and 2 squared is 4. I'm going to do 3 minus 1, 3 minus 2, which is 1. And then I do 3 minus 5, which is a -2, which gives me a -8. So that's the point, 3, -8. And now I'm going to find out what happens at 4. So now I do 4 minus 1. 4 minus 1 is 3. 3 squared is 9. 3 minus 2, 4 minus 2 is 2. And then 4 minus 5 is a negative 1. So this gives me a negative 18. So that's the point for negative 18. So I'm going to go down to negative 20. And this will be negative 10. And so here we'll have 10 and 20. The y-intercept is at positive 10. At 3, it's at negative 8, which is going to be about here. And at 4, it's going to be at negative 18, which is about here. Now when I do f of 6, I'm betting f of 6 is going to be like f of negative 1 is going to be relatively large. So it's not going to fit in my graph. But I want to find it because it's an appropriate point to tell me how quickly it's climbing. It's going to be climbing pretty fast. So I'm going to do 6 minus 1 is 5, and 5 squared is 25. So right away, we're going to be large numbers because we're only going to be multiplying. 5. 6 minus 2 is 4. So we're already up to 100. And 6 minus 5 is 1. So this is 100. So I have 6 comma 100 is another point. So that's even higher than my 72. 72 is going to be so way too high. So the only other point I want to find out is what happens between 1 and 2. So I go for 1.5. There's a number of ways of doing this. I'm going to use 3/2. My own screen. Nope, I'm not. Went too far off screen. I'm going to use 3/2. So 3/2 minus 1 is 1/2, and 1/2 squared is 1/4. 3/2 minus 2, that's 3/2 minus 4/2, which is a negative 1/2. And then I'm going to do 3/2 minus 5. 5 is 10/2. So 3 minus 10 is 7. So that's a negative 7/2. I multiply the numerators, I multiply the denominators. So at 1.5, at 1.5, negative times negative is positive. So 1 times 1 times 7 is 7 in the numerator, and 4 times 2 times 2 is 16. So that's 7/16. Or you could do it by punching it into the calculator, either way, and using 1.5. So you have 1.5 squared is 0.25. And this you get a negative 0.5. And this you would get 1.5. That's going to be a negative 3.5. And so you multiply those three numbers together, and it'll give you a negative point something. No, a positive point something. I don't know what it is. And but one is right about here. And so 7/16 is just below a half. So we go just above, right about at a half there. So it barely bounces back up before it takes another nosedive. And it plummets down this way. It goes up like that. And over here, it's going to go through there and go up very fast. So that's what it kind of looks like. If you type this into a graphing program, like Desmos or something like that, or use a graphing calculator. Have your y limits be -10, -20 to +20, and your x range or domain be from, I would go -3 to 10 or above 6, or the lowest I would go is 7 over here. But I go ahead and have this 10 and either have this be a -3 or a -5. I don't need to go all the way down. I just need to show, I could even just go to -2 here, just to show how quickly it's going up. But the smaller your X range, the more you can see the details. And you can even bring the upper range up here to 15, but leave this one at 20, -20. To show you, it's going to look very similar to what I've drawn here. And because of the limitations in the pixels, this may look like it's just right on the line. So it may not even show it going up to a half, depending upon how many pixels the pixels determine how accurate the graph looks. That's why using Desmos, it would show a better picture. Including the stuff I erased. Anything you have questions about? Graphing the polynomial function is the harder of the three questions only because of the list. And you have 11 things to do. And not everybody remembers how to do the Descartes rule of signs. Please remember how to Descartes rule of signs. Each one of these, I think I'm going to have them worth, in the past, I've had them worth the 3 points. But I'm going to have them be each problem here being worth 5 points. So that this one problem will be worth 55 points. So on numbers 1 and 2, where you have 8 problems, each one of those is going to be worth 40 points. So that means this exam is going to be worth 135 points unless I put in other problems. But they won't be, you only have 3 graphing problems. The other problems I might put on there deal with other. I might ask you to write a system of equations as an augmented function. There should be, give me 10 points. that's 11.2. Please be in there doing the homeworks, please. Chapter 3 and most of chapter 4 is what this exam is covering. A little bit of chapter 2, I think, but not much of it. And 11.2 might be included. I didn't tell that to my 10 o'clock class. So I said may proceed might be up. Any questions on this? I do not see this as difficult work. I see it as time consuming, tedious, and it could be confusing, especially when we start using fractions or decimals to calculate extra points. And since you're allowed to use a calculator, I go ahead and use a 1.5. And so the work I would show there for 1.5 is I would do a 1.5 minus 1 squared times 1.5 minus 2 times 1.5 minus 5. F of 1.5. That's what F of 1.5 is doing. And then you just give the answer, which in this case was 7/16, but it'll give you a decimal number, which will be just under a half, 4 point something, or 3 point something. It's going to either end in, it's going to end in 2.5, but is it 125, 325, 725? Those are the possible last 3 digits, or 250. Somebody punch that in a calculator and tell me what the decimal number is. I think it's going to be 4 point something. I mean, 0.4 something. 1/8 is 1 point is 0.125. Half of that is 0.0. 0.06.
Like 0.0675, I think.
To subtract that from 0.5, and that will be, what'd you say? 0.4.
0.5 minus 0.0675. So that should be about 0.4325.
I said the last 2, this was a possible selection for the last 3 digits. So I got that, I guess that's where I didn't guess it, I knew. So when you punch it in the calculator, this is the number you get. Because that's going to be 0.25 times 0.5 times 3.5. So I have 1, 2, 3, 4 decimal places. So my answer is going to have 4 decimals. So when I multiply 25 times 5 times 35, I get 4,325. But 4 decimal places. I'm gonna need 4 decimal places, so that's all my digits. So all my digits are to the right of the decimal. Any other questions here? I'm gonna start erasing things. Because we're gonna do another one. I think we have time for 2 of these more. I know I did the, which one was it? What was the other one I did? Whoops, that's the wrong, there it is. I did number, what was it? I did number 9 the other day, I think in here.
I think it was 8, if I remember correctly.
Oh, 8, did I do 9?
I can't recall.
X cubed minus 7x plus 6. Where the x squared is missing.
That
I
does not
think we
sound
did
familiar.
number 8.
Yeah, we did 8, 9. The one you just said does not sound familiar.
Okay. I know I did it in one class, so that meant I did it in my 8 o'clock class yesterday. And I know I did it in my 10 o'clock class today. So we have f of x equals x to the third minus 7x plus 6. A lot of the problems I've been doing have a plus 6 at the end. I have to rectify that. That's too many. Because those are nice ones to put on the exams. I can't put them on the exam if you have them on review sheet. Well, technically I can, but I don't. Now, I already stated it, but what's missing here? That's something you should notice right away. Are all the terms there?
No, we're missing x squared.
Yeah, we're missing x squared. So what's the coefficient of x squared?
1.
If it was 1x squared, wouldn't it be here?
0. My bad.
There you go. Because we're always adding 0. So 0 times something, I can always add in there. So 0 times x squared is what's missing. So when I go to find the linear factors and I use a synthetic division, I know my coefficient of x squared, because when doing the synthetic division, you need all the coefficients. So that's for looking ahead. And that's something we do. So describing the end behaviors deals with the leading term. Y equals x cubed. With y equals x cubed, what are the end behaviors?
Down to the left, up to the right.
What did you say?
Oh, it started as it goes negative, it heads to the left. As it's positive, it goes to the right. Sorry,
As
bad wording. Down to the
goes
left, up to the
negative,
right.
It goes to the left. Is that what you said?
Yeah, down to the left, up to the right.
Up to the left, down to the, no. Say it again.
Down to the left, up to the right.
There you go. Down to the left, up to the right. You can either write it that way, using the arrows, or you can write it using what you were, I think what you were saying was, as f of x goes to negative infinity, no, f of x goes to negative infinity as x goes to negative infinity. And f of x not equals, but goes to positive infinity as x goes to positive infinity. So the direction x is headed, that's the same direction y is headed. Does that make sense? As x goes positive, y goes positive. As x goes negative, y goes negative. For x squared, x cubed, the graph of that looks like something like this, so you could draw that. That tells me human behavior. All odd degree power functions where the leading coefficient is 1 have this shape to them. X to the 5th, x to the 7th, x to the 239th have this shape to them. The leading coefficient just either makes it happen faster or slower, because if it's a fraction, then it's going to be compressed. And if it's a number larger than 1, then it's going to stretch out. And if it's negative, it just switch. So if this was a negative here, then it would go up to the left and down to the right. So it would be coming down, coming from the second quadrant to the 4th quadrant. But this comes from the 3rd quadrant and goes into the 1st quadrant when x is sufficiently large. So now letter B is we're going to find all the possible rational zeros. So how do we find the possible rational zeros? How do we do letter B? Tell me. That's what you're going to have to do on the exam without me helping you.
Switch all the signs.
No, that's for letter C. Letter C is Descartes' rule of signs, and that's determining what happens with the sign changes.
We're doing the P over Q, right? Where it's all the
P over Q.
yeah
So
factors.
what-
of the constant.
What does that mean, P over Q?
We're getting all the factors of the constant. We're using doing the fraction P over Q, where as Q is the the fractions of the leading coefficient. So P would be positive or -1, positive -2, positive -3, or positive -6, and P would be positive or -1.
Well, you just told me that P is going to be the factors you said.
1, 2, 3, and 6 all positive or negative, as where Q would be just positive or -1.
Okay. Because Q are the factors of what? What are Q the factors of?
Leading coefficient in this case is
And so we want the P over Q,
yes.
which is dividing each of these numbers by each of these numbers, which just gives us all the P values back, right?
Yes.
So when doing this, you will get all the factors of the constant, and sometimes you'll get additional ones that will be fractions. And sometimes those fractions reduce to one of these numbers. So that's something to be aware of. Because when you're listing things, you're not listing how many times they show up, you're just listing what they are. So we were listing the zeros here on the previous problem. One showed up as a zero more than once, but we only listed it once. And we talked about its multiplicity to take care of the fact that it showed up once. So this was B. Now C, yeah, we changed signs, but do we change all the signs?
No.
F of negative x. When you put when you put negative x in for x, is the 6 going to change its sign?
No.
No, because it's a constant. Constants never change. Okay. Kind of harped on that way too much the other way. So what happens with x cubed? What does it become? If it has an odd degree, it's going to change. If it has an even degree, it will not change. Because when you square a negative, it stays positive, becomes positive, and so multiplying by a positive does not change the sign. But when you square it, when you raise a negative to an odd power, it stays negative, and so it's going to change the sign of the constant, of the coefficient. So this is going to become a negative x cubed, and this will become plus 7x plus 6. For f of x, how many sign changes are there?
Two.
There are 2 sign changes. So the number of positive zeros is what? Number of positive real zeros is how many?
Possibility of
What's the maximum number of positive real zeros we can have?
2 or none.
2 or none. Thank you very much. Because the number of sign changes is the maximum number of positive we can have, which is 2. And then you subtract 2 until you get to 1 or 0. So you have 2 or 0 or none. Positive real zeros. Now on f of negative x, how many sign changes? Because that will tell us the negative number of real zeros. So how many sign changes in negative f of negative x? How many times did it say change signs? Or technically, how many times did the sign vary?
1 time.
1 time. So how many was the maximum number of negative zeros?
1.
1. So we're guaranteed a negative real zero. So we will have a real zero that is named. And this was letters. Now, checking for 1 and negative 1 to be zeros. Well, that's as easy as adding the coefficients here. If I do f of 1, so that's just going to be 1 cubed times 1. 1 times minus 7, and then the constant. So that's just going to be 1 minus 7 plus 6, which is just the coefficients of that function. And that does, in fact, equal 0. So 1 is 0. So I answered portions of E, F, and G. That means we have 1 as a 0 here. That means x minus 1 is a factor, and that means 1 comma 0 is an x-intercept. Or you could just list the number 1. But I like to list it as a point. Now we're going to do f of negative 1. F of negative 1, you get the coefficients of f of negative x, which is negative 1, positive 7, I wrote a 6, positive 7, and plus 6, because that's the constant. And this just gives us 12. Well, 12 is not 0, so that's an appropriate point that we can use, negative 1, 12. It may not fit with what we're graphing, but chances are we're going to be able to graph that point. It'll help us with the graphing. So that means negative 1 is not a 0. So this is the work for letter D. Now, listing the zeros, well, we already found 1 0, so I'm going to do synthetic division with that 1, with that 0. That 0 is 1. Okay. Now I need all the coefficients here. Remember when we first discussed what was happening with that function? We have one of the terms missing, and so we discovered that its coefficient is 0. So x cubed, its coefficient is 1. X squared, its coefficient is 0. X, its coefficient is a negative 7, and the constant is 6. And I better get a 0 over here, because 1 is a 0. That means the remainder will be 0. So we drop down this 1, multiply by 1, combine 1 with 0, we get 1. A lot of 1s there. 1 times 1 is 1, another 1. Okay, and then negative 7 plus 1 is a negative 6. 1 times negative 6 is negative 6. And those are opposites, so they go to 0. So boom. So we factored this to x minus 1 times x squared plus x minus 6. I already got the 0 off of negative x minus 1. Now I need to get a 0 off of this quadratic. So this is the the depressed equation. So I set that equal to 0, but first I'm going to factor it. And it's going to equal 0. The leading coefficient is 1, so it's going to be an x and an x. Now I want the factors of 6 that subtract to 1. Well, 3 times 2 is 6, and 3 minus 2 is a positive 1. And so that means the 3 has to be plus, and 2 is minus. Now I set each of those factors here equal to 0. And I get x plus 3 equals 0, or x minus 2 equals 0. So x equals a negative 3, x equals a positive 2. So there I have 2 more zeros. Okay. Already factored it to x minus x plus 3 and x minus 2. And I have negative 3 and 2 as zeros. I can have at most 3 real zeros and I have 3 real zeros. 2 of them are positive, and 1 of them is negative. It fits everything I've dealt with so far. Right, since 2 and -3 are zeros, that means 2 is an x-intercept and -3 is an x-intercept. And now for the easiest question to answer, what is the y-intercept? 0 what?
Six.
And I have not had my Zoom window up, so if anybody's been typing in the chat, I've missed it. But I got it up here. Okay. So 0, 6. The constant is the y-intercept. Because when I put, and if you want to show work here for this, you just say f of 0 equals 0 minus 7 times 0 plus 6, which is 6. Or 0 to the 3rd power, yes, technically. That would be a more accurate way. So now we need to start listing other points. So to start listing other points, we want to look at what's happening with the graph. And so -1, -2, 3, because -3 is a 0. And I know this is the furthest to the left it goes as far as the zeros are concerned. So the end behavior means it's going down from this point. So I'm just going to find out where it is at -4, just to find out how quickly it's dropping. And it might be an appropriate point to actually graph, but it's definitely an appropriate point to put here. And I'm going to find out what happens at -2 and well, I already found out what happened at -1. So that means I need to add -2 to find. We know what happens at 0, it went up to 6. And then my other 2 zeros are at 1 and 2. So I'm going to look at what happens at 3. And I'm also going to, again, I'm going to look at what happens at 1.5. And I would use 3/2 in this case because I do. And since at 2 is the furthest right of our x-intercept, so that means to the right of this point, the function is going up. So that graph will go up this way. And so now we look for other points so we can refine here. I want to find out what happens at -2. So I'm going to put -2 in for x. And I can either do the synthetic division again, or I can use the factored form. I like using the factored form because it gives me numbers I can do mental arithmetic. So putting -2 in, f of -2, -2 minus 1 is a -3. -2 plus 3 is a +1. And -2 minus 2 is a -4. Yeah, it's going to be positive. So that's going to be a -3 times a -4, which is a +12. So at -2, we wind up at 12 again. And then at 6, it's going to be, at 0, it's going to be at 6. So, yeah, okay. And I want to look at what happens at what half. But if I go to 15, actually, if I have this be 6 and this be 12 and this be 18, so this will be 24. And so here I have -6 and then -12. and then negative 18 and negative 24. So far graphing, I have these points. I like to graph them. And once I set the scale up, I start graphing the points as I find them. And now I'm going to look at what happens at 1.5. 1.5 will give me a number that is negative. So 1.5 minus 1 is 1/2. F of 1 and 1/2. So 1.5 minus 1 is 1/2. 1/2 plus 3, 1.5 plus 3 is 4.5, and 4.5 is 9/2. And then 1.5 minus 2 is a negative 1/2. And I knew it was I needed to get a negative number because it passes through at these 2 points because their multiplicity is 1. So the only way the two sides of the graph can meet is if it's negative. And so my numerator is going to be 9, and it's going to be a negative fraction, and that's 9/8, negative 9/8. Which is just a little bit below -1. So that's going to come down about this far, not very far. So it's barely going to go down. Now, when I put 4 in, I have 4 minus 1. When I do f of, so I have 1.5 or 1.5 and a negative 9/8, which is a negative 1.125. So if you did all of this in the calculator, you would get decimal numbers here, and they would multiply to negative 1.5, negative 1.125. So now I want to do -4. -4 minus 1 is a -5. -4 plus 3 is a -1. And -4 minus 2 is a -6. So I'm multiplying 3 negatives together, so it's going to be a negative answer. And 5 times 1 times 6 is 30, so that's a -30. So at -4, we go to -30, which I can put that on here. So this would be -30, so that would be right here. So it's going to come up like this, through here and come back down. Go through here and go back up. And so at 3, what's going to happen at 3? So now I want to find out what happens at f of 3. 3 minus 1 is 2. 3 plus 3 is 6. And 3 minus 2 is 1. So this is going to be 12. So at 3, it goes to 12. So I have three x values that give us 12, which is fine. So that changes my trajectory there. And there you have it. If you graph this in a graphing calculator, it probably won't show much, depending upon your like I would do this from negative 36 to 18 in my y direction. So this isn't going to show much separation between this point and the x-axis. If it shows any at all. Because of the pixel flip. And there we be done. Any questions here? So what you have with what you have is you've got a review for the final. I mean, for the exam too. And we've been working these problems for 3 or 4 days now. And we'll do it again for the review. And the review is me answering questions, me dealing with issues you have with the problems you're trying to crack. That means if nobody has any questions, then we're going to have a very short class, which is a shame, because I'm sure some of which if you don't have any questions, you understand it perfectly. That's what I want. That means everybody gets 100. There are 2 types of exams that I love grading, only because they're super easy. One of them makes me very happy, and the other one makes me very sad. The one that makes me very sad is people who hand in exams with no answer. That is super easy to grade. That's a 0. But it makes me sad because why? And then 100, yeah, that makes me happy because I just look at everything is correct. There's no wrong answers. That's easy. Yeah. I go through and check. It's not as quick to grade as a 0 is, but it makes me very happy when I get 100s on. Realize I'm looking for mistakes. I had a professor one time who said that there's absolutely no test you can do for me that you will get 100 on. It was a geology professor. And there was a Ron Price. His name was Ron Price. I remember his name. He was an older student. We were in our early 20s and he was in his mid 30s. And he came back, he already had a degree in accounting or something else and wanted to go into geology and work in petroleum. And so, yeah, he came back to school and on one test, he made a 98 on that exam. And the professor said he had to look hard and long to find that 2 points. And so everybody said, well, there's nowhere else but down from here. And lo and behold, he made 100 on the next test. And the professor said to the whole class, I looked through that test 4 or 5 times trying to find a point to take off. Because nobody gets a perfect exam. And so, but I revel in perfect exams. But again, like Professor Freed, I look for mistakes. So if all you did was a minor mistake of changing a sign, I'm going to take off that point. But if that's the only mistake you make. Or you like you got -3, but when you wrote it in the answer spot, you told me that the answer was +3. That's a -1. That's a transcription. Which sometimes I forgive, but if that's the only mistake you made on an otherwise perfect paper, I'm taking that point. Yeah, I can be a bastard. That's what all my online friends tell me. All right, I've been rambling on. Any questions about this? Any questions about the exam? That you can ask me now. Then you can ask me again next Monday. But when the exam day comes next Wednesday, I'm not answering any more questions. If you have a question about the exam when you're working it, you ask me in chat, under private chat, a direct message. And I will answer as best I can without actually giving the answer. So sometimes that means I can't answer that question. That's something you need to know. So just be aware of the fact that documentation is important. You have to when you go out in the workplace, you have to document a lot. You have to document how come you did what you did. You have to document why it has to go this way. You have to document what you found out. You need to keep records. That's what all the work is the record of how you got your answers. You're documenting your results. This is nothing you won't get asked to do in the real world outside of college. Some of y'all may actually have to do that already. You have to justify or verify that you did something. That's what I'm doing here. You have to verify and justify. You have to justify your answer, and you have to verify that you did the work by showing me the work. Even if you're just punching it into the calculator, where did I put that? Can I do that? Yeah. If you're punching it into the calculator, so like putting what was it, 1.5? I could say I'm doing f of 1.5 is going to be 1.5 cubed minus 7 times 1.5 plus 6. This is telling me that this is what you're putting into the calculator. And then it equals, did I say that was, that's going to be a negative 1.125. So this here, all this work here verifies it's the work for finding this point. And whether you write it as -9/8 or -1.25, I don't care. As long as you show me the work of how you got that number. So if this number ends up being wrong, because you typed it in wrong, or something like that happens, then I can see what happened. I can see that you got the wrong number because you typed it in incorrectly, not because you did it wrong. And I can forgive points that way. So if you got the wrong answer, but you showed me you were getting it the right way, I may not take off any points. Unless this number is used later on for some other calculation, then I'll probably take off a point. But because this is just a point, this is the end result for a point, I may not take off any points. I might take off one. It just depends on how severe the error is. If it showed a positive number when you knew you should have gotten a negative number, and then you didn't check your, whenever using a calculator, do it twice, at least twice. I call it the fat finger syndrome, where you hit two keys at the same time. Or if you have long fingernails and you're not being careful, well, sometimes my fingernails get long enough that I hit the button above instead of the button I wanted to hit. That changes my calculation. Now I'm rambling on, and we're at time. So unless you have questions for me, you're free to go. And I will see you Monday. Look for more things being put into the files for exam 2 for the review. Otherwise, enjoy your weekend when it happens for you.
You too.
Man, that was an annoying sound. I didn't even listen to that. All right. As soon as I'm done erasing, I'm gonna exit the meeting. On my feet since not here. My feet are killing me.
Sir,
Yes.
we have office hours this week, so I can like work on the review with you. Or some help.
I have a meeting at 3 o'clock today. So if you want to discuss things with me, send me an email and we'll set up a time.
Okay.
I have no problem either later today or tomorrow. Sometime, I mean, yeah, later today or during tomorrow office hours. Just be sure you email me, because I don't always put up my office.
Okay.
I just need to be reminded to put up my office on Tuesdays and Thursdays. And Friday, as long as you email me, I can set up a time on Friday just to open up the Zoom and sit there and wait for you. I do that. I mean, Friday. Just go in there and have my Zoom open from like 9:30, 10 o'clock. For a couple hours.
All right, sir. I'll send you an email.
Okay,
Have a good day.
you too. All right, Destiny, Ruby, all right, Ruby's gone. Giovanni, I say that right, Giovanni? All right, I'm gonna end the Zoom. And we'll see you